we have to find the average temperature during a period of time from 9 in the morning until 9 at night, and that is based on the fact that the temperature is fluctuating according to this equation right here. Now, to calculate the average value of a function, we have learned that we can apply this formula here. This formula uses the notation f of x, but if we look at our equation, it's actually capital T as a function of lowercase t. So in other words, it's temperature as a function of time. So we have actually rewritten the formula below using that notation for the function. And then instead of f average, we're going to have t average. But basically, it's the same equation. And what we need to first do is figure out the value of a and b, which represent the lower and upper limit, respectively, that we will be integrating across. Now, we must take note that the time is measured in the number of hours after 9 a.m. So at 9 a.m., there would certainly be 0 hours after 9 a.m., so this just means that our lower limit, a, is going to equal 0. And then at 9 p.m., well, that's 12 hours after 9 a.m., so that means our upper limit, b, is going to equal 12. So there we have our a and b, and then of course our function, t of t, is given in the question. So we're going to come down here, and we're going to begin to plug in. So we can say that the average temperature is equal to 1 over our upper limit, which was 12, minus the lower limit, 0, multiplied by the integral from those same limits, and then our temperature function. So that's just the 50 plus 14 sine of, now they write pi t over 12. I prefer to write that as pi over 12t. And then we're integrating with respect to t. So perhaps the greatest challenge of this question is to integrate this function. Integrating a constant is relatively easy, but integrating this function here is a little bit more challenging, and we may want to go off on the side and talk about how to integrate that. And to actually integrate that part of the function, one thing we could try is a u substitution, and that's what we're going to do here. So we'll do that as an aside, and we're going to let u equal, now with a trigonometric function, it often is effective to let u equal this part of that trigonometric function. So we're going to give that a try. We're going to let u equal to pi over 12t. And then we, using this method, must take the derivative of this equation. So the notation here would be du dt. And then the derivative of pi over 12t, remember, pi over 12 is a constant, and the derivative of a constant multiplied by the variable is just the constant. So in other words, the derivative here is just pi over 12. Now, if we're going to integrate this, it usually is helpful to solve this for dt. So to do that, we'll multiply both sides by dt. The dt's cancel out on the left-hand side, so now we have du is equal to pi over 12 dt. And then in the spirit of solving for dt, we could multiply both sides by the reciprocal of this pi over 12. So in other words, multiply both sides by 12 over pi. Like that. Then the pi over 12s cancel out on the right-hand side. So now we have 12 over pi du is equal to dt. So we can now integrate this expression. We would have the integral of 14. We don't want to forget that 14 was a coefficient here. And then that's sine of, and then instead of pi over 12t, remember we're making a substitution. So pi over 12t is going to be substituted with u. And then instead of the dt, we're going to fill in what we solved for dt right here. So that's going to be multiplied by 12 over pi du. Now, this is a little bit easier of an integral. We do have some constants here that we can factor out. So we have 14 multiplied by 12 over pi. So we're going to work that out in just a second. And then we have the integral of sine of u du. Now, we can simplify the 14 times pi over 12. 14 times 12 is 168. So you're going to have 168 over pi. And then the integral of sine of u is negative cosine of u. So you can actually put the negative out here and then put the cosine there. That is the integral, but let's not forget that we're doing a substitution method and that we had let u equal pi over 12t. So we definitely want to make sure we put that back in here. So this is negative 168 over pi, and then the cosine, and again, the u was equal to pi over 12t. So that completes that very long aside. We do need to return back to the main problem. Just hold on to this integral in the back of your mind right now. We return to the integral that we were evaluating. Maybe we can come down here and continue it. So we have the average temperature is equal 1 over 12 out front multiplied by the integral. Now, the integral of 50 with respect to t is just 50t. So that's relatively easy. And then we did the aside to figure out the integral of what is in that green circle, and that was that minus 168 over pi cosine of pi over 12t. So we'll just sort of copy and paste that and put it right there. And then we have our limits from 0 to 12. You'll probably remember that the next step would be to plug the upper limit in first. So we're going to be plugging the 12 in for all of the t's. And then after simplifying that, we'll also plug the 0 in for the t's. So the 12 goes in first. This 1/12 on the outside, you can kind of factor that out. So you'll just have 1/12 multiplied by the entire expression that follows. So you're going to have the 50 times the 12 minus 168 over pi cosine. Now in here, you're going to be multiplying pi over 12 by 12. But of course, if you multiply pi over 12 by 12, the 12s cancel and just give you pi. So if you want, you can just write pi right there. So that's what we would have from plugging in the 12. This is getting to be a lot of parentheses, and then we'll plug the 0 in. So you're going to plug 0 in. 50 times 0 is 0, so you can just put a 0 there. And then minus, we're going to need to clear out some room here. And then we're going to have 168 over pi cosine. When you plug 0 into t here, pi over 12 times 0 is 0, so this just becomes the cosine of 0, like so. And we do need to be careful because when we subtract here, we're going to need to put that quantity in parentheses. That was the quantity we derived by plugging 0 in for t. The reason being is that minus sign is going to need to distribute. So it doesn't really matter to the 0, but when you distribute over here, that's going to make this become a plus sign. So do be careful about distributing that sign, that minus sign. So now we have 1/12, and then let's see what we have inside. So 50 times 12, that should be 600. And then here you have the cosine of pi, and the cosine of pi is just -1. So you're going to have minus 168 over pi multiplied by -1. When you multiply that by -1, that just changes this into a plus 168 over pi. So that's nice and easy. Over here, like I said, you have to distribute that minus sign, so you're going to end up with a plus 168 over pi. And then the cosine of 0 is just 1, so you'll be multiplying this by 1, which doesn't change its value. And so this is the expression that will represent the average temperature. We could clean it up if we want to get a little fancy. 168 over pi plus 168 over pi. You just add the numerators and you get 336 over pi. If you'd wish, then you can distribute the 1/12, excuse me. 1/12 times 600 should just be 50. So you get 50 plus, and then 1/12 times the 336 over pi is 336 over 12 pi. Looks like 336 does divide by 12. So 336 divided by 12 is 28 with a pi underneath. And that would be the final answer for the average temperature. And then you could punch that into a calculator to get an approximate value. And if you did that, it's about 58.9 degrees. And they measure temperature in Fahrenheit. So that would be an approximate answer to the question. Thanks for taking the time to watch the video. If you're interested in making a small donation to my cause, I'd greatly appreciate it. Of course, don't feel obligated. Appreciate you taking the time to watch the videos regardless.